Welcome. This video is based upon derivatives past paper questions of paper 1, 2, 3 for IBDP AHL. The first question. The following diagram shows a ball attached to the end of a spring which is suspended from a ceiling. The equation is given. He is asking find the height of the ball above the ground when it is released. When it is released means time should be equals to 0. So h of 0 equals to 0.4 cosine 0 plus 1.8, which is 2.2 meters. Find the minimum height of the ball. Minimum height of the ball. Minimum height means we know that cosine x will be having a minimum as -1. So it's going to be minimum height is going to be 0.4 times -1 plus 1.8, which is 1.4 meters. Part C, show that the ball takes 2 seconds to complete to return to its initial height. Means it is completing one period. We know that period of cosine is nothing but what? 2 pi. If at all it is cosine ax, the period is going to be 2 pi upon absolute value of a. Now I have cosine pi t. So its period is going to be 2 pi upon pi, which is going to be 2 seconds. For the first 2 seconds of the motion, determine the amount of the time the ball is less than this particular height. So for that, 0.4 cos pi t plus 1.8 should be equals to 1.8 plus 0.2 root 2. 1.8 gets cancelled. 0.4 cos pi t equals to 0.2 root 2. Cos pi t equals to 0.2 root 2 divided by 0.4. So cos pi t equals to root 2 upon 2. This is basically 45 degrees. General solution for cos is 2n pi plus minus pi by 4. So I take 2n pi plus pi by 4 and 2n pi minus pi by 4. When n equals to 0, I get pi upon 4 or negative pi upon 4. Negative angle is rejected. N equals to 1, I get 9 pi by 4, which is more than 2 seconds, and 7 pi by 4. So pi t is either equals to pi upon 4 or 7 pi upon 4. So t value is 1 upon 4 or 7 upon 4. So the duration will be, he is asking us for the duration. So it will be 7 upon 4 minus 1 upon 4, which is 6 upon 4, which is 1.5 seconds. Find part E, find the rate of change of ball's height above the ground. So h of t equal to 0.4 cos pi t plus 1.8. So h prime t will become negative 0.4 because cosine derivative is negative sine. Pi t derivative is pi sine of pi t plus 0. Now I'll find it 1 upon 3. So which is negative 0.4 pi sine pi upon 3. Then sine pi upon 3 is root 3 upon 2. So it's going to be negative 0.2 pi root 3. But he says p is a rational number. So 0.2 should be written as 1 upon 5 pi root 3 meter per second. This is going to be the answer. Question number 2. The population of a particular species is given by this formula. In the context of the population model, interpret the meaning. What is dp upon dt? We know p is the population. So therefore, what am I going to write it out? Rate of growth. Rate of growth of the population. Now he's asking us to find the second derivative of that. So we know that dp upon dt equals to kp times 1 minus p upon n. So I have to find the second derivative. So I'll expand this one, kp minus kp square upon n. Now I find the second derivative, dt square equals to k times p derivative is dp upon dt minus k upon n. P square derivative is 2p. Again, chain rule, dp upon dt. Now what can I do? I can take k dp upon dt as common. So what am I left over with? 1 minus 2p upon n. This is going to be the answer. But again, dp upon dt. What is dp upon dt? dp upon dt is itself is k times p times 1 minus p upon n times 1 minus 2p upon n. So it becomes k square p times 1 minus p upon n times 1 minus 2p upon n. This is the second derivative. Now, hence show that the population of the merospheres will increase at a maximum rate. Maximum rate. The rate should be maximum. What was the rate? This one. This one should be maximum. If this one should be maximum means its derivative should be equals to 0. Its derivative should be equals to 0. What is its derivative? Its derivative is the second derivative. So, second derivative should be equals to 0. d square p upon dt square should be equals to 0. Means k square p 1 minus p upon n 1 minus 2p upon n should be equals to 0. So, either I get p equals to 0 or this one should be equals to 0 means 1 minus p upon n should be equals to 0 or 1 minus 2p upon n should be equals to 0. So either p equals to 0, from here I get p equals to n or p equals to n upon 2. These are the three conditions. Now p equals to 0 is not possible because the population cannot be 0. The maximum population cannot be n also. Then only the possibility is p equals to n upon 2. Next, hence determine the maximum value of dp upon dt. So we know that it is p as n upon 2. So I quickly add a page there. So now we know what is dp upon dt. dp upon dt equals to k times p times 1 minus p upon n. But p is n upon 2. So n upon 2, 1 minus n upon 2 upon n. So it's going to be nothing but what? Kn upon 2 minus 1 minus 1 upon 2. So Kn upon 2 times 1 upon 2, which is Kn upon 4. Next condition. If P0 is the initial population of the merospheres, by solving the differential equation, show that its solution can be expressed in this form. So, as such we are doing based upon differentiation. This one is based upon the integration. When I do the video for the integration, this will be covered. This comes under integration part, E and F. So, this video is exclusively only for differentiation. Question number 3. Consider this function. Write down the y-intercept of the graph. So, he's asking us to write it out the y-intercept. Y-intercept means nothing but what? X should be equals to 0. So let me copy down this one and create a space for this. Copy and paste it out over here. He's asking us to find the y-intercept. Y-intercept means for part B, y-intercept. Y-intercept means x equals to 0. Substitute. So y equals to 0 plus 0 minus 1. So y equals to negative 1. So y-intercept is 0 comma negative 1. Sketch the graph for f of x between my negative 3 to 3 and y value this one. And it is a paper 2 question. So graphing calculator is allowed. So when you do by graphing calculator, approximate shape I am showing it out. You may be getting it out in this way. This is 3 and this is negative 3. Then the function has one local minimum point at x equals to p and local maximum and minimum. Determine the range for f of x, p equal to x to q. So if you are using the GDC, then directly you should be getting it out. F of x should be lying between negative 1.27 and 1.33. Into question number 4, differentiate by using the first principles. So limit h approaches 0, f of x plus h minus f of x divided by h. So limit h approaches 0, 3 of x plus h whole cube minus x plus h minus of 3x cube minus x divided by h. So When I expand this one, limit h approaches 0, 3x cube plus 3x square h plus 3x h square plus h cube minus x minus h minus 3x cube plus x divided by h. Then limit h approaches 0, 3x cube plus 9x square h plus 9x h square plus 3h cube minus x minus h minus 3x cube plus x divided by h. Then 3x cube gets cancels. 3x cube and 3x cube gets cancels. X and x gets cancels, and that's it, I think so. So the remaining terms will be limit h approaches 0, 9x square h plus 9x h square plus 3h square minus h upon h. You can cancel one h term in both the numerator and denominator. 9x square plus 9xh plus 3h minus 1. Now plug in h is 0. I am left over with only 9x square minus 1. That's going to be the answer. 5. Point A has a coordinate and B has a coordinate. He is asking find the coordinates of the midpoint. So midpoint formula we know x1 plus x2 upon 2 comma y1 plus y2 upon 2. So over there negative 2 plus 4 upon 2 and negative 8 plus 4 upon 2. So it's going to be 1 comma negative 2, and this is point C. D has a coordinate. Find the gradient of DC. So gradient formula y2 minus y1 upon x2 minus x1. What are y2? This is x1 y1 this is C is x1 y1 and D is x2 y2. I'm going to find it out the gradient. So it's going to be 1 minus of minus 2 divided by negative 3 negative 1, so which is negative 3 upon 4. Find the equation of a line in this form. So when we know the point and an equation gradient, so y minus y1 equals to m times x minus x1. So y minus 1 equals to negative 3 upon 4 times x plus 3. So what does that becomes now? Y equals to negative 3 upon 4x, negative 9 upon 4 plus 1. So y equals to negative 3 upon 4x, negative 5 upon 4. Coming to question number 6. The following diagram shows the part of a graph of a function f. The function f has a vertex 3, 4 and passes through Q. Write down the equation of the axis of symmetry. Axis of symmetry will be x equals to 3. The function can be written in the form of a times x minus h whole square. Find the values of x and h. So basically, as the vertex is 3, 4, so it should be a times x minus 3 whole square plus 4. So h is 3 and k is 4. The point Q has a coordinates 5, 12. Find the value of a. Now we know that 5, 12 should be lying on this one, a times x minus 3 whole square plus 4. So 12 equals to a times 5 minus 3 whole square plus 4. So 4a plus 4 equals to 12. 4a equals to 8. A equals to 2. Find the equation of L. What is L? L is the tangent at Q. So first of all, I'll find f prime x. F prime x is nothing but what? My f of x is over here is 2 times of x minus 3 whole square plus 4. What is f prime x? 4 times of x minus 3. Now I want at Q. So gradient of the tangent at Q will be 4 times of Q coordinate. What are the coordinates of Q? 5, 12. So 5 minus 3, which is going to be 8. So the gradient is 8. So equation will be y minus y1 equals to m times x minus x1. So y equals to 8x minus 28. Now consider another function y equals to g of x. The derivative of g is given by g prime x equal to f of x minus d. Find the values of d for which g of x is an increasing function. Increasing function means g prime x should be greater than 0. So f of x minus d should be greater than 0. The f of x minus d should be greater than 0. So f of x, when I see this vertex, this distance is nothing but how much? 4. That distance should be greater than 0. 4 minus d should be greater than 0. So 4 is greater than d, or else d should be less than 4. Then it will be always an increasing function. For an increasing function, the first derivative should be greater than 0, g prime x, but g prime x is f of x minus d. We can see the vertical height of f of x is 4. So 4 minus d should be greater than 0. Coming to question number 7. Do we have another part for this? Find the part E also is there. Find the values of x for which the graph is a concave up. For concave up, what should I be doing? Second derivative should be greater than 0. So second derivative will be greater than 0. If the second derivative is greater than 0 means my first derivative should also be greater than 0. So what was first derivative? 4x minus 12 is greater than 0. So x minus 3 is greater than 0. So x is greater than 3 for concave up. Now question number 7. Consider the function with the domain x lies between a and b. The following diagram shows the graph of f prime, the derivative of f. The graph of f prime, the derivative of f, has an x-intercept at p, x equals to 0 and x equals to t. There are local maximum points at x equals to q and x equals to t, and a local minimum point at x equals to r. Find the values of x when the graph of f is increasing. Justify your answer. So it is an increasing function. It is an increasing function when the first derivative is positive. We can see the first derivative is positive from p to 0. So x lies between p to 0. That is one of the way of doing it out. So because it's a positive gradient, so it is having an increasing function. Find the value of x when it has a local minimum value. Find the value of x where the graph has a local minimum value. Local minimum value is going to be nothing but what over here. So local minimum value x equals to 0. Find the value of x where the graph f of x has a local minimum value. That was local maximum value was that x equals to 0. Now coming to local minimum value. Local minimum value is going to be how x equals to 0 is local maximum value, because you can see that the derivative was positive over here and the derivative is negative over here. It is becoming positive, 0 and negative. So it is going to be a maximum value. So x equals to 0 is going to be a maximum point. Whereas at p, it was negative, it became 0 and it became positive. So negative, 0 and a positive. So it is going to be minimum value. So at x equals to p. And justify your answer, you can see that the derivative changes from negative to positive. Therefore, it is going to be a local minimum value. Then C2, find the values of x where the graph has a point of inflection. So we have to find it at the point of inflection wherever the what is this? If this is the graph, its derivative should be second derivative should be equals to 0. At p, it is second derivative is equals to 0, and at r, second derivative is equal to 0, and at t, the second derivative is equals to 0. Second derivative should be equals to 0. Where is it at? It is at x equals to q, x equals to r, and x equals to t. Find the total area of the region enclosed by the graph. This one. So The total area of the region enclosed by the graph f prime and the derivative of f and the x-axis is 20. Given that f prime f of p plus f of t equals to 4, find the value of f of 0. Now this is again from integration concept. When we are doing the integration topic, then we will be continuing with this question. So this video is exclusively based upon differentiation. Coming to question number 8, this is a function f is defined, f of x equals to sine inverse of x squared minus 1 by x squared plus 1. Show that the function is an even function. For even function, what is the condition is f of negative x should be equals to f of x. So instead of x, if I plug in negative x, wherever x is there, I am plugging in negative x, I should be getting the same question. Do I get the same question over there or same function? Yes, it is nothing but what? F of x. So this is f of negative x. I replaced x with negative x and I got it out same f of x. So therefore, it is an even function. Coming to part B. By considering the limit, show that the graph f of x has a horizontal asymptote. For horizontal asymptote means the line should have a, what is this, y equals to some constant. It should have a gradient equals to 0. Gradient should be equals to 0 or y equals to some constant. Now, what am I going to do that? For that, what is this? As x tends to infinity. We know that as x tends to infinity, f of x will become sine inverse of, what is that? Infinity upon infinity, which is nothing but what? 1, arc sine 1, which is nothing but what? Pi by 2. So therefore, y equals to pi by 2 is going to be my horizontal asymptote. Part C, show that f prime x equals to this one. So find the derivative. So what am I going to do? F of x equals to sine inverse of x square minus 1 upon x square plus 1. So f prime x. So let me add a new page and write it out everything over there. So f prime x. F prime x equal to sine inverse derivative is y square 1 upon 1 minus square root of 1 minus x square, which is x square minus 1 upon x square plus 1 whole square times chain rule. Times you need to find the derivative of this entire thing. For that I'm doing the quotient rule again. X square plus 1 whole square, x square plus 1 times x square derivative is 2x minus x square minus 1, again x square derivative is 2x. So when I simplify that, this square goes to the numerator, square and square root gets cancelled, so I just get only x square plus 1, and in the denominator it is x square plus 1 whole square minus x square minus 1 whole square. If you don't understand this step, let me write one more step there. 1, I took a common denominator, x square plus 1 as a common denominator over there. Let me write it out neatly. 1 upon this entire square root. What is a common denominator? X square plus 1 whole square is a common denominator. X square plus 1 whole square minus x square minus 1 whole square times, for this part, x square plus 1 whole square, then this is 2x cube plus 2x minus 2x cube plus 2x, then 2x cube gets cancelled, this square and square root gets cancelled, and this goes to the numerator. So I'm left over with x square plus 1 in the numerator. Denominator is a square minus b square. A square minus b square can be written as, this is a square minus b square. Formula is a plus b times a minus b. X square plus 1 plus x square minus 1. X square plus 1 minus x square plus 1 times 4x upon x square plus 1 whole square. I can cancel 1 x square plus 1. 1 cancels, x square gets cancels. I am left over with 4x divided by, this is 2x square and 2x, so which is 4x square, and 1 upon x square plus 1. So what am I left over with? 4x upon 2 square root of x square times 1 upon x square plus 1. then it becomes 2x upon square root of x square, 1 upon x square plus 1. That's going to be the answer for the part CI. Now by using the expression of f prime x and the result that square root of x square is equal to absolute value of x, show that f of x is decreasing when x is less than 0. So let me add a page over there again. So x is less than 0. X less than 0 means absolute value of x equals to negative x. So what will be f prime x will become minus 2x upon x square plus 1. So therefore it is always a decreasing function. Because first derivative is negative means it is a decreasing function. Next, a function g is defined by g of x such that part D g of x equals to sine inverse of x square minus 1 upon x square plus 1. Find an expression for g inverse x. Is asking us to find it out for a function for g inverse of x. So let this be equals to y. So y equals to sine inverse of x square minus 1 upon x square plus 1. So sine y equals to x square minus 1 upon x square plus 1. So cross multiplication x square sine y plus sine y equals to x square minus 1. X square sine y minus x square equals to minus 1 minus sine y. So x square common, sine y minus 1 equals to minus 1 minus sine y. So x square equals to minus 1 minus sine y divided by sine y minus 1. So we can take off the minus common and cancel it out. So x square equals to negative of 1 plus sine y divided by, take minus common, 1 minus sine y. Then minus minus cancel. So x equals to square root of 1 plus sine y divided by 1 minus sine y. So therefore g inverse of x will become square root of 1 minus sine x divided by 1 plus sine x. That is part D. Hence he is asking us to, in part E, find the domain of g inverse of x. What's going to be the domain? So we are all talking about x. So x should be lying between negative pi by 2 to plus pi by 2. So sin x, it should be lying between negative pi by 2 to plus pi by 2. That is the domain for sine. Next, sketch the graph of y equal to g inverse of x, clearly indicating any asymptotes. Write the equations and stating the values of any x-intercepts. So now we know that the domain is from minus pi by 2 to plus pi by 2, negative pi by 2 and positive pi by 2. Last time, if we remember, that the horizontal asymptote was y equals to pi by 2. So this time it will become the vertical asymptote. So pi by 2 becomes the vertical asymptote. This is a vertical asymptote, and when I plug in 0, g inverse of 0 will give me square root of 1 minus 0 by 1 plus 0, which is 1. So 0, 1 is 1 point. 0, 1 is 1 point, and we have already learned that in the g inverse of x domain has been found, and this now as it going to pi by 2, positive pi by 2, it becomes positive infinity. So it will be somewhere over here. And if I plug in negative pi by 2, g prime of negative pi by 2, it will become 0 over there. So because if I plug in there, I will be getting it out 0 Let me make a correction over here. So if I do negative pi by 2, it becomes square root of 1 minus 1 divided by 1 plus 1 will become 0. So at negative pi by 2, it is going to be 0. So just join it out these points. So how do I get it out a rough sketch for this one? A rough sketch looks like this. This is going to be the shape of the graph, approximate shape of the graph. Next, question number 9. The question asks paper 3 question for 31 marks. This question asks you to explore the behavior of some key features of the function fnx where a belongs to r plus and n belongs to z plus. In the parts a and b, consider only the case when a equals to 2. Consider f1x equals to x times 2 minus x. Sketch the graph of this one. So let me add a page over there and start doing it out the entire solution. So now f1x equals to x times 2 minus x. So it is a parabola having the roots at 0 and 2. 0 and 2. And it is a inverted parabola because it is minus x square. So draw an inverted parabola with minus x square. And we need to know the maximum point also. So because in the question is asking what is the maximum point and the minimum point. So it is 2x minus x square. So I find the first derivative. 2 minus 2x, equate first derivative to 0. So x equals to 1. Plug in x equals to 1. So we will be getting y equals to 2 minus 1, which is 1. So 1 comma 1 is going to be my maximum point. So I find the maximum point. Then use the graphing display calculator to explore the graph for odd values of n and even values of n. Hence copy and complete the following table. So when you do the what it says, you can do it out by graphing calculator. I'm directly writing it out the answer over here. So I copy the table over there. When I do n equals to odd numbers, you can see that it will be having only one maximum point, and what is this minimum points are there are no minimum points. 0 is there, and number of points of inflection you can just check it out 2. Check in the graphing calculator and see that whether these your answers and my interpretation is correct or not. When n is even, you will be getting it out 1 maximum and minimum points and 2 minimum points, and inflection points will be 0. You can check that one in the graphing calculator for this part. Now part C, show that the first derivative of fn, it is been asked part C, fn derivative will be n times x power n minus 1 a minus 2x times a minus x whole to the power of n minus 1. That is been asked in part C. So first of all, I should be writing it out. What is fnx? So given fnx equals to x power n times a minus x whole to the power of n. Now use the product rule. So what am I going to do that? N times x to the power of n minus n times x to the power of n a minus x to the power of n minus 1, minus x derivative is minus, plus n times x power n minus 1 times a minus x whole to the power of n. So This is u, this is v. So I did u, v prime, then u prime and v. Next, when I take n times x power n minus 1 common and a minus x to the power of n minus 1 common, so I'm left over with one more a minus x minus x. So that should be giving me the answer n times x power n minus 1 a minus 2x times a minus x whole to the power of n minus 1. That is a part C. State the three solutions of fn prime x should be equals to 0. So we have to prove that three solutions are there. What are those three solutions? So either x equals to 0, or if this term equals to 0 means a minus 2x equals to 0, or else a minus x equals to 0. So either x equals to 0, x equals to a upon 2, or x equals to a. Then part E, show that the point a upon 2, fn a upon 2 on the graph, and fn is always above the y-axis or the horizontal axis. Now we know that fn of x equals to x power n times a minus x whole power n. So fn of a upon 2 equals to a upon 2 whole power n, a minus a upon 2 whole power n. So which is a upon 2 whole power n times a upon 2 whole power n. So which is a upon 2 whole power 2n. So which is nothing but what? A upon 2 whole power n and whole square, which is always a positive term, which is always greater than 0. So the first fn of a upon 2 is always greater than 0. Next, hence or otherwise show that fn prime a upon 4 is greater than 0. Hence or otherwise. So fn prime a upon 4, plug in that fn prime a upon 4 value, then wherever x is there, substitute a upon 4, then I get it out, this one. So what does it becomes? N times a upon 4 whole power n minus 1, a minus a upon 2 is a upon 2, 3a upon 4 whole power n minus 1. Now we know that n is positive, a upon 4 this one is positive, a upon 2 is positive, and a upon 4 any number is all positive. So product of all numbers is always positive, numbers is always positive. So therefore this is greater than 0. So fn prime a upon 4 is greater than 0. Next, now coming to G1, he is asking, by using the result of part f and considering the sign of fn prime negative 1, show that 0 comma 0 is the minimum point and it's a maximum point. So for this first one, he is asking show that it is a minimum point for values of n is even. So first of all, we are going to consider what is fn prime x. It is nothing but what? N times, what is that one? We have just found it out, the formula for that, n times x power n minus 1, a minus 2x, a minus x whole power n minus 1, a minus 2x and a minus x whole power n minus 1. Now I'm going to find it out, negative 1. Already we have found, again we will find it out. So it becomes n times, over here let me copy it, x power n minus 1. So let me move this one over here somewhat and have negative 1 whole power n minus 1. So it becomes negative 1 whole power n minus 1, then a plus 2, then a plus 1 whole power n minus 1. Now if n is even, the first case is n is even. If n is even, n times negative 1 whole power n minus 1 will become negative n, which is less than 0. A plus 2 is a positive number. A plus 1 whole power n minus 1 is a positive number. So product of all these three, product, because we need to multiply, right? Product of all these three is negative number. So what can I say? Negative 1, if it is even number, it's going to be a negative. So the derivative is negative. Then at 0, it is going to be 0. And at a upon 4, it's going to be positive. So your derivative become negative, negative, 0 and positive. Negative, 0 and positive. So it's going to be a, what is this, minimum point. That is the way how to prove it as minimum point. Now for the part 2, what is being asked? Show that it is a point of inflection. Point of inflection for G2 is asking show that it is a point of inflection with zero gradient for values of n if n is odd. If n is odd, in that case what should I do? N times negative 1 whole power n minus 1 will become positive number is equals to n. If at all it is odd, it's a positive number. So a plus 2 is a positive number. A plus 1 whole power n minus 1 is also a positive number. Now the product of all these three is nothing but what? Positive. So we know that again. First derivative at my negative 1 equals to nothing but what? At 0, it is 0. And at a upon 4, it is again positive. So what is that? It is positive, 0 and still positive. So therefore, it is going to be a point of inflection. That's going to be the answer for G2. Now, lastly, part H. By considering y equals to x power n times a minus x whole power n minus k, then state the conditions for n and k so that x power n times a minus x whole power n equals to k has 4 solutions. It should have 4 solutions. So first of all, we know that n should be an even number. N should be even number, then only we'll be having a minimum of 4 solutions, because in an even number, then only the curve goes up and down in symmetrical order. So n should be even number. And apart from that, if x is a upon 2, I write over here a upon 2, x as a upon 2, so I get a upon 2 whole power n times a upon 2 whole power n minus k. So k value should equals to 0. So k value should be a upon 2 whole power 2n. So k value should be always from positive number to maximum a upon 2 whole power 2n. That are the values for k. Now the next question number 10. Consider the curve y equals to so on. Sketch the curve. Now sketching the curve, this is from graphing calculator paper 2, so you can use the graphing calculator to sketch the curve. And I'm drawing it out. It looks approximately, this is 2 and negative 2 over here, negative 1 and up to 3, and this is 12. This is the approximate shape of the graph. A teacher asks her students to make some observations about the curve. Nadia said the x-intercept of the curve is between negative 1 and 0. Rick said the curve is decreasing at x equals to 1. Paula said the gradient of the curve is less than 0 between x equal to 1 and 2. State the name of the student who made an incorrect observation. So, first of all, Nadia. Nadia said that the x-intercept is between negative 1 and 0. Yes, it's correct. So, Nadia is correct. Now, what about Rick? Rick said the curve is decreasing between x is less than 1. X is less than 1. Over here, if at all I have 1, it is an increasing function. It is going up. So, Rick is wrong. What about Paula? The gradient of the curve is less than 0 between x equals to 1 to 2. Yes, 1 to 2, it is coming down. So, Paula is correct. Next, find dy by dx. So our dy equals to 2x cube minus 9x square plus 12x plus 2. So what will be dy by dx? 6x square minus 18x plus 12. Show that the stationary points are 1 and 2. So for the stationary points, what should I be doing it out? First derivative should be equals to 0. So x square minus 3x plus 2 equals to 0. So x minus 1 times x minus 2 equals to 0. So x equals to 1, x equals to 2. Given that y equal to 2x cube minus 9x square has 3 solutions, find the possible value of k. So part F, and we see that it is a paper 2 question, so graphing calculator is allowed. What you can do it is when you graph that one, you can see that find the, if at all a line is over here, you can have 3 solutions, and over here between these two, so you can see that this is 6 and 7. 6 and 7, so k lies between 6 and 7. From the graphing calculator you can see that the values of k is 6 and 7. Now coming to the next question, b1, expand f of x. So when you expand it out, directly I'm writing it out, you should get 10x minus 2x cube plus 10 minus 2x square. Find f prime x. This is directly derivative again, 10 minus 6x square minus 4x. Draw the graph for f of x. It's a paper 2 question, so you can use a graphing calculator to draw the graph. So it should be somewhere over here like this. This is -3, -1, 10, and somewhere between 2 and 3. Write down the coordinates of the graph g of x is given. Write the coordinates of the points of intersection. Again, draw that graph, and your point of intersection should be 1.49 comma 13.9, and that's all. Only one point of intersection. Now coming to the next question, f of x equals to ln 5x upon kx. Show that f prime x equals to this one. So what am I going to do? I am going to do by quotient rule. So this is the quotient rule. So we have a numerator and a denominator. So I am doing by the quotient rule. So let me write that one. F of x equals to ln 5x divided by kx. Ln 5x divided by kx. So f prime x will become kx whole square. Kx times ln 5x derivative is 1 upon 5x times 5 minus ln 5x. Kx derivative is k. So it becomes k minus k ln 5x divided by k square x square. 1 k gets cancels. 1 minus ln 5x divided by k x square. Then f prime x has been found it out. Part B, the graph of f has exactly one maximum point. Find the y coordinate of P. So he's asking for only one maximum point. So means f prime x should be equals to 0. So 1 minus ln 5x divided by kx square should be equals to 0. 1 minus ln 5x equals to 0. Ln 5x equals to 1. 5x equals to e. X equals to e upon 5. That is the value of x coordinate. Now As he asking x coordinate, then the second derivative is given. The graph of f has exactly one point of inflection. Show that the x coordinate is of q is this one. So for point of inflection, what am I supposed to do it out? The second derivative should be equals to 0. For point of inflection part C, second derivative should be equals to 0. So 2 ln 5x minus 3 upon kx cube should be equals to 0. So ln 5x should be equals to 3 upon 2. 5x equals to e power 3 upon 2. X equals to 1 upon 5 e power 3 upon 2. Then the region R is enclosed by the graph, x-axis, vertical lines ensure that. Find the area of this one. So for finding this area, this entire part is again comes under the integration. So when we do this integration video, then we will be able to do that. This video is exclusively for differentiation. To question number 13, the displacement has been given by s of t equals to t square cos t plus 2t sin t. Find the maximum distance. Maximum distance means use the GDC to draw the graph and find the maximum point. So we'll be getting it out. Maximum point as 1.51986. Now the acceleration of the particle means the second derivative. Find the second derivative. Use again GDC to find the second derivative of this and substitute this point. You should be getting it out minus 8.92. You write the units centimeter per second square. Next question, paper 3 question. The question asks you to investigate some properties of the sequence of function of the form fn x equals to cos inverse x and so on. Important, when sketching the graphs in this question, you are not required to find the coordinates of any axis intercepts or coordinates of any stationary points unless requested. On the same axis, sketch the graph for y equal to fn x, y equal to f3x, and for x lies between -1 and +1. So because being a paper 3 question, what you can do it is you can use the graphing calculator to get the graph. I had a page over there. I am drawing it out. It should be somewhere like this. This should be the shape of the graphs. Then next one, for odd values of n is greater than 2, use your graphing display calculator to systematically vary the value of n and suggest an expression for odd values of n describing in terms of n the number of maximum and local points. So you can use your graphing calculator and try for n equals to 3. You will be having one maximum point and one minimum point. When you try for n equals to 5, you get 2 maximum and 2 minimum. When n equals to 7, you get 3 maximum and 3 minimum. You can check this one with your GDC. So the formula is going to be nothing but what? N minus 1 upon 2. Now coming to B2, the local minimum points. So how many maximum points? N minus 1 by 2 maximum points. Similarly, in B2, he's asking how many minimum points. It's going to be the same, n minus 1 upon 2 minimum points. Now, in part C, let's go to part C. Over there, on the new set of axes, y equal to f2x and f4x, we have to draw it out. So I'm going to draw that one. You can sketch that one by using the graphing calculator. I get a curve in this way and another one It starts from same and goes over here and comes and touches over here. This should be the approximate shape of the graph. And now for part D1, he is asking for even values of n is greater than 2. Use your graphing display calculator to systematically vary the value of n. Hence, suggest an expression for even values of n describing in terms of n. Local maximum points. So, for n equals to 2, I get 0 maximum and 1 minimum. You can check by the GDC. For n equals to 4, I get 1 maximum and 2 minimum. And n equals to 6, I get 2 maximum and 3 minimum. So what is the formula that you can see that? For maximum, n minus 2 by 2. Maximum points for n minus 2 by 2. Whereas for minimum points, it's going to be n upon 2. Now for part E, what is being asked in part E there? Solve the equation fn prime x equals to 0. Fn prime x equals to 0 and hence show that the stationary points at x equal to so on. So therefore f1 f, so what has been given? Fn of x has been given, which is cos n cos inverse of x. So fn prime x will be, cos derivative is nothing but what? Minus sine n cos inverse of x, and cos inverse of x derivative is negative 1 upon 1 minus square root 1 minus x square. So negative negative gets cancels and again times n, chain rule. So n sine n cos inverse of x divided by square root of 1 minus x square. Now it should be equals to 0. This should be equals to 0. So what do I get it out? N sine of n cos inverse of x should be equals to 0. So n cos inverse of x should be equals to 0. Sine inverse 0. Sine inverse 0 is 0. So n cos inverse of x should be equals to k pi. Because multiples of pi will be always equal to 0. Sine multiples of pi is always equals to 0. So from there, cos inverse of x equals to k pi upon n. X equals to cos of k pi upon n. That is what being asked us to prove. Then in part F, use an appropriate trigonometric identity to show that f2 of x equals to 2x square minus 1. So what is f2 of x? f2 of x equals to cos of 2 cos inverse of x. So which is cos of, we use a formula. What formula we are going to use? Cos 2x is 2 cos square x minus 1. So I'm going to use that identity. What is this? Cos 2a equals to 2 cos square a minus 1. So I'm going to use that identity and get that one. So it becomes 2 cos square of cos inverse of x whole square minus 1. We know that cos and cos inverse gets cancelled. So what does it becomes? 2x square minus 1. So part G, use an appropriate trigonometric identity. So let me copy the part G entire thing over here. So use an appropriate trigonometric identity to prove this one. So fn plus 1 x equals to cos of n plus 1 cos inverse of x. So it becomes cos of n cos inverse of x plus 1 cos inverse of x. I'm expanding it out like this. Now then I use the identity cos a plus b. What is cos a plus b? Cos a cos b minus sin A sin B. So it becomes cos of n cos inverse of x, cos of cos inverse of x, cos A cos B, minus sin of n cos inverse of x, sin of cos inverse of x. I think so. That is only been answers to prove. Hence show that fn plus 1x, fn minus 1x equals to 2x of fnx. So basically in the same way, fn minus 1x will become cos of n minus 1 of cos inverse of x. So it becomes cos of n cos inverse of x minus cos inverse of x. This time I'm going to use cos A minus B formula. What is that? Cos A cos B plus sin A sin B. So it becomes cos of n cos inverse of x, cos of cos inverse of x plus sin of n cos inverse of x, sin of cos inverse of x. Now we are supposed to add both fn plus 1 x plus fn minus 1 x. When I add this one, so let me copy them down. This is fn plus 1 x for value. I copy paste over here and add it with this one. When I'm going to add it out, we can see that these two terms gets cancels. So I'm going to get 2 cos of n cos inverse of x and cos of cos inverse of x, which is nothing but what? Cos and cos inverse gets cancels, so 2x, and this is fnx. That's what is asking us to prove it out. Now, hence, express f3 of x. So f3 of x will be 2x f2x minus f1x. From there, we can get that one. So n equals to 2. So this is a formula. Let me write that one step by step, then it will be easy to understand. So what is the formula that we have just now proved it out? Fn plus 1x plus fn minus 1x equals to 2x fnx. Now let's substitute n equals to 2. So what does it becomes? f3x plus f1x equals to 2x f2x. So what is f3x will be equals to 2x f2x minus f1x. 2x f2x is just now, what is f2x we have learned? 2x square minus 1. f1x is x. So it becomes 4x cube minus 2x minus x. So it becomes 4x cube minus 3x. Now coming to the next one, paper 1 question. So it should be an easy question. Question number 15. A function f is defined by f of x equals to this much. Sketch the graph y equal to f of x. Indicating the asymptotes, writing their equation, stating the coordinates of any points of intersection with the x-axis. So we have 3 upon x square plus 2. So this is a bottom heavy equation. Bottom heavy equation means my horizontal asymptote will be the x-axis. Now what is the thing is, there is no vertical asymptote. Now where does it intercept the x-axis, y-axis? Y-intercept will be nothing but what? Means x equals to 0. So plug in, you will be getting it out 3 upon 2. So 0 comma 3 upon 2 is going to be the y-intercept. And x-axis is going to be the asymptote, horizontal asymptote. So approximate graph should be, this is 0 upon 3 upon 2, and it should be in this way. This is the shape of the graph. Next, B part, show that the area again this comes under integration, so therefore we are not doing for now. This part is under integration. We will do separately in an integration video. Same, part C is also based upon integration. Now, given that m is the gradient of the curve, show that m equals to, gradient means this is derivatives, we can do that one now. So, dy by dx. So, y equals to 3 upon x square plus 2. So, I'm going to find dy by dx. So, it's going to be 3 times x square plus 2, negative 2, negative 1, because this can be written as 3 times x square plus 2 whole to the power of negative 1, times again x square derivative. What is x square derivative? 2x is the x square derivative. So what does that becomes now? Negative 6x upon x square plus 2 whole square. This is going to be the gradient and the value of m. Show that the maximum value of m is this one. So dm upon dx equals to, do the quotient rule, or I'm going to do it as quotient rule for that. X square plus 2 whole square will become whole power 4. So x square plus 2 whole square times negative 6 minus negative 6x, then 2 times of x square plus 2 and again 2x. Now I take x square plus 2 common, because there is x square plus 2 over here, x square plus 2 over here common, and 6 over here, 6 over here common, 6x square plus 2 common. So what am I left over with? 1 more x square plus 2, then minus times minus is plus, plus, but whereas be careful over here. So what is left over? Let me write it out there. Yes, negative symbol and 1 more x square plus 2. So negative x square, negative 2, and 2, 2x is left over, and this x is also left over. So what is that? And minus times minus is plus. Then and 4. So plus 4x square is left over, divided by x square plus 2 wholes to the power of 4. So 1x square plus 2 gets cancelled. So this 4 becomes 3. So 6 times of 3x square minus 2 divided by x square plus 2 whole cube. This is the first derivative. And we have to prove that for the maximum point, first derivative should be equals to 0. So 3x square minus 2 should be equals to 0, x equals to plus or minus 2 upon 3. Then he is asking us to, in the question, it is asking show that the maximum value. So we get two values. One value of x is negative square root 2 upon 3. Another value of x is positive square root 2 upon 3. Now, as such, we have to find one is maximum point and one is minimum point. So which is maximum and which is minimum? So we know that maximum occurs at negative 2 upon 3 and minimum occurs at positive 2 root 2 upon 3. Now for that, what am I going to do? I am going to find the second derivative and plug in x equals to negative 2 upon 3, and I am going to get a negative answer. Therefore it is maximum. Find the second derivative and substitute x equals to positive square root 2 upon 3, you get a positive answer. Therefore it is maximum. And what is that maximum value? Negative 6 upon negative 2 root 2 upon 3 divided by Negative root 2 upon 3 whole square plus 2. So when you simplify that, I'm directly writing 27 upon 32 root 2 upon 3. So coming to question number 16, he says a circle with an equation x square plus y square equals to 9 has a center 0, 0 and radius 3. Now he's asking show that a point Q lies x, y lies on that. Show that Q equals to y square root of y equals to square root of 9 minus x square. So what should I be doing it out for this? Now we know that x square plus y square equals to 9. So y square equals to 9 minus x square. Y equals to plus or minus square root of 9 minus x square. But Q is on the positive y axis. So therefore plus square root of 9 minus x square. So you need to mention this point also, otherwise you will be losing marks for that. Next, find an expression for A, area of the triangle. So area of a triangle is half base times height. So we need to consider the base and we need to consider the height also. So base, you can see that it is 2y. This is a base which is 2y. So which is 2 times of square root of 9 minus x square. Height, it is from here to here, which is x plus 3, because this is x and this is 3. So the height is going to be x plus 3. So what's going to be the area? Area is, let me quickly add a page over there. So area is going to be half base is 2 times square root of 9 minus x square and height is x plus 3. So what's going to be the area? Area is x plus 3 times square root of 9 minus x square. Now part C. Show that dA by dx equals to 9 minus 3x minus 2x square divided by square root of 9 minus x square. So what am I going to do? I am going to do the product rule. dA by dx equals to x plus 3 as it is. Square root of x derivative will be always 1 upon 2 square root of 9 minus x square. X square derivative is minus 2x. Plus next time 9 minus x square as it is and x plus 3 derivative is 1. Then I take the common denominator, square root of, because 2 and 2 gets cancels, square root of 9 minus x square is the common denominator, minus x times x plus 3, then 9 minus x square, square root 9 minus x square root multiply, it becomes 9 minus x square. So it becomes negative x square, negative 3x plus 9 minus x square upon square root of 9 minus x square. So what does that becomes now? It becomes as 9 minus 3x minus 2x square upon square root of 9 minus x square. That is dA by dx. Coming to part D. Part D is asking y coordinate of R such that A is maximum. So whenever maximum or minimum, first derivative should be equals to 0. 9 minus 3x minus 2x square upon square root of 9 minus x square should be equals to 0. So 9 minus 3x minus 2x square equals to 0. Factorize it out. I'm directly writing the factors. X plus 3 should be equals to 0. So x equals to either 3 by 2 or x equals to negative 3. So x cannot be negative 3. So only x equals to 3 by 2 is going to be the answer. Now, what is he asking in this question? Y coordinate of y. So therefore plug in this x value in the y coordinate, because when you are plugging in this, you should be careful that I am taking negative side. Okay, so y is negative because for getting the what is this r, it is negative y, and getting the q, it is positive y. So I simplify that. I'm directly writing the answer. It is negative square root 27 upon 2. Consider the next. I think so that ends the question. Answer otherwise y coordinate of r. R is negative, so therefore that's going to be the answer, such that A is maximum. Okay. Coming to the next question. A narrow passageway. So consider the following diagram which shows the plan of a part of a house. A narrow passageway with 3 upon 4 meters width is perpendicular to the room 6 meters. So this height is 6. This is 3 upon 4. Show that L. What is L? Length of that. So you have to read the question carefully. He's asking show that L. So we know that L equals to, from the diagram, AC plus BC or CB. So first of all, I'll take in the smaller triangle AC. So this is also angle alpha. So cosine alpha equals to 3 upon 4 upon AC. So AC equals to 3 upon 4 upon cos alpha. So AC equals to 3 upon 4 secant alpha. Similarly, in this triangle, cosine alpha equals to 6 upon cosine alpha. Rather than cosine alpha, I take sine alpha. Sine alpha, because opposite side is 6, 6 upon CB. So what is CB? 6 upon sine alpha. So which is 6 cosecant alpha. So now AC is 3 upon 4 secant alpha plus 6 cosecant alpha. Now B1. Find DL upon D alpha. So 3 upon 4 secant alpha derivative is secant alpha tan alpha. Cosecant alpha derivative is minus cosecant alpha cot alpha. B2 dl upon d alpha equals to 0. Show that alpha equals to tan inverse of 2. So 3 upon 4 secant alpha tan alpha minus 6 cosecant alpha cot alpha equals to 0. So 3 upon 4 secant alpha means 1 upon cos alpha. Tan alpha means sin alpha minus cos alpha. 6 cosecant alpha means 1 upon sin alpha. Cot alpha means cos alpha upon sin alpha. Now, can anything be cancelled? Nothing can be cancelled. So, what we can do it is sin square alpha multiplied with this sin alpha, it becomes sin cube alpha. Cos square alpha multiplies with this cos alpha will become cos cube alpha. Then 3 times 1, 3 times 2. So sin cube alpha equals to 8, because this 4 and 2 gets multiplied, 8 cos cube alpha. So divide by cos cube alpha on both sides. What do I get from there? Tan cube alpha equals to 8. So tan alpha equals to cube root of 8. So what is tan alpha? Tan alpha equals to 2. Alpha equals to tan inverse of 2. Then C part 1, find d square L by d alpha square. So dl upon d alpha is 3 upon 4 secant alpha tan alpha minus 6 cosecant alpha cot alpha. We have to do the derivative of this one. So d square L upon d alpha square, 3 upon 4 product rule uv, uses uv, secant alpha as it is, tan alpha derivative is secant square alpha. Next time, tan alpha as it is, secant alpha derivative is secant alpha tan alpha. Then again, this is u and this is v. So negative 6 cosecant alpha as it is, cot alpha derivative is nothing but what? Minus cosecant square alpha, minus 6 cot alpha as it is, cosecant alpha derivative is minus cosecant alpha cot alpha. So when I simplify, directly I'm writing that answer. You should be getting 3 upon 4 secant alpha tan square alpha plus 3 upon 4 secant cube alpha plus 6 cosecant alpha cot square alpha plus 6 cosecant cube alpha. Then part C2, alpha is tan inverse of 2. Then show that d square L upon d alpha square equals to 45 upon 4 square root 5. So tan alpha equals to 2. Secant square alpha equals to 1 plus tan square alpha. So secant square alpha equals to 1 plus 2 square. Secant square alpha equals to 5. Secant alpha equals to square root of 5. Then right angle triangle 2, 1 square root of 5. So from here I can find sine alpha is 2 upon root 5. So cosecant alpha I require, which is root 5 upon 2. Now plug in all, then cot alpha. Tan alpha is 2, cot alpha is 1 upon 2. So those are the things I require: secant, tan, cosecant and cot. Now plugging them: 3 upon 4 square root 5 2 square plus 3 upon 4 square root 5 whole cube plus 6 times square root 5 upon 2 times 1 upon 2 whole square plus 6 times root 5 upon 2 whole cube. 12 root 5 upon 4, 15 root 5 upon 4, 3 root 5 upon 4, 15 root 5 upon 4, which is going to be 45 upon 4 root 5. Then hence next part D1, hence justify L is minimum when alpha is tan inverse 2. So when you substitute, d square L upon d alpha square will be greater than 0. So and dl upon d alpha equals to 0 when alpha equals to tan inverse of 2. Therefore it is going to be minimum. Determine the length of L. Part 2. So L equals to 3 upon 4 secant alpha plus 6 secant alpha. So simplify: 15 root 5 upon 4. Last part, part E. Two people want to make a pole of length 11.25 to enter into the room. Determine whether it is possible, giving your answer. 11.25 can be written as 15 root 9 upon 4. But the maximum length is nothing but what? 15 root 5 upon 4. So which is greater than the length. So therefore, what is the thing is, we are going to write cannot be carried. Question number 18. Sketch the graph of f double prime x. So paper 2 question, you can use the calculator to get that point. I'm using the calculator to get it out over here, then somewhere over here, and at 1 over here. Then I join this is the approximate shape. Find the x-coordinate of the point of the inflection. So wherever the second derivative is equals to 0, f double prime should be equals to 0. So it is 0.524 from the calculator and 0.785 from the calculator. Next, hence find the values of x for which the graph is concave down. Concave down. So between 0.524 and 0.785. Question number 19. Find f prime x, which is x square plus 2x minus 15. Find the values of a and b. As a horizontal tangents means the derivative should be equals to 0. Factorize it out. You should be getting x plus 3 or x plus 5 times x minus 3 equals to 0, x equals to negative 5, x equals to 3. And he told that a is less than b. So a is negative 5 and b is 3. Sketch the graph of f prime x. So negative 5 and 3. And negative 5 and 3, these are the roots. So join it out, negative 5 and 3. Hence, explain why the graph has a local maximum point at x equals to a. At a, why it has a maximum point? It is being asked us to prove it out or ask the reason for that. So, when you see that this one, the derivative was positive, then it became 0 and it became negative. At negative 5, it was positive, 0, it was positive, positive, 0 and negative. So it is going to be a maximum point. So you need to write f prime x changes from positive to negative. That's why it is a maximum point. D1 f double prime b. So first of all, what is f double prime x? Which is 2x plus 2. So f double prime of 3 will be 2 times of 3 plus 2, which is going to be 8. Hence, use your answer in D1 to show that the graph has a local minimum point at B. We know that second derivative is positive. If second derivative is positive, means it is going to be minimum point. The normal to the graph, part E. The normal to the graph at x equals to a and tangent to the graph at x equals to b intersect at P and Q. So, normal to the graph at normal at x equals to a. But what was a value? A was negative 5. So slope of the tangent at x equals to a is, it is a parallel tangent 0. So slope of the normal will be 1 upon 0. Means it is going to be a vertical line. It's a vertical line. So it will be in the form of x equals to k. Any vertical line will have the form x equals to k. And over here x equals to minus 5. That is the one. Then tangent at this one, at b. So b equals to how much? 3. So f prime of 3, f of 3. When I do f of 3, I get 10. Now this is parallel to x-axis. Means y equals to k is negative 10. So y equals to negative 10. That's going to be the equation of the tangent. Now both they meet. Minus 5 and minus 10 will be the point of intersection. P is minus 5 and Q is minus 10. You can clearly see that. This is the graph. X equals to negative 5 and y equals to negative 10. Negative 10 and negative 5. So where do they meet? They meet at negative 5 comma negative 10. Question number 20. It is already been done over here. So it is a repeated question. You can check, reverse back the video and check that. Question number 21. Show that P perimeter of ORST. So this is X. This is Y. So perimeter equals to 2x plus 2y. So 2x plus 2 times of y. Y is 4 minus x square. So it becomes minus 2x square plus 2x plus 8. Determine the dimensions of the rectangle has a maximum perimeter. So dp by dx should be equals to 0. First of all, to find maximum or minimum, dp upon dx should be equals to 0. So minus 4x plus 2 should be equals to 0. X equals to 1 upon 2. Substitute to get the values of y. Y equal to, this is 4. Then that will be 15 upon 4. So what will be the perimeter? Negative 2x square plus 2x plus 8. So negative 2 times 1 upon 2 whole square plus 2 times 1 upon 2 plus 8. Simplify that, which is 17 upon 2. Maximum perimeter. Next, Find an expression for area. Area equals to length into width. So x times 4 minus x square, which is 4x minus x cube. Find the dimensions at maximum area. For maximum area, dA by dx should be equals to 0. 4 minus 3x square should be equals to 0. X square equals to 4 upon 3. X equals to plus minus square root of 4 upon 3. I take only plus because x cannot be negative. So y value will be 4 minus 2 upon square root 3 whole square, which is 8 upon 3. Hence find the maximum area. Maximum area will be equals to 16 upon 3 root 3 or 16 root 3 upon 9. This question is also a repeated question. Go back to the video and check that. This is also a repeated question. Question number 23. Find the value of t. The acceleration is 0. Velocity is given. Means find the derivative of it. dv by dt should be equals to 0. Paper 2, you can use directly the GDC and find the derivative and equal to 0. You will be getting t value as 0.465. S1 is the distance from 0 to t, capital T, and S2 is the distance from capital T to t equals to 1. Show that S2 is greater than S1. This is again based upon integration, so we shall do in that particular integration video. Now question number 24. E power 2y equal to x cube plus y. So e power 2y derivative, e power 2y derivative 2 dy by dx equal to x cube derivative 3x square plus y derivative dy by dx. So dy by dx common, 2 e power 2y minus 1 equals to 3x square. So what is dy by dx? Dy by dx equals to 3x square upon 2 e power 2y minus 1. That is dy by dx. The tangent, part B, the tangent at C is parallel to y-axis. Means dy by dx should be equals to 1 upon 0. Means 2 e power 2y minus 1 should be equals to 0. 2 e power 2y equals to 1. E power 2y equals to 1 upon 2. Apply ln on both sides. Ln 1 upon 2. 2y equals to ln 0.5. Y equals to minus 0.346. Substitute this value of y. You should be getting it out the x value as 0.946. Question number 25. An object moves on a straight line is given. Find the displacement of this. So basically, if at all you want to do from velocity to displacement, it is integration. So we shall be continuing this one in the next video when there is integration. Find an expression for acceleration. So just find the derivative. Minus 3t square plus 7t minus 2. Greatest speed reach before it comes to rest. Means acceleration should be equals to 0. Greatest speed means acceleration should be equals to 0. Acceleration equals to 0. So minus 3t square plus 7t minus 2 equals to 0. Factorize it out. 3t minus 1, t minus 2 should be equals to 0. T equals to 1 upon 3 or t equals to 2. Substitute these values. The greatest speed you will be getting it as 8 meters per second. Largest positive value 2. This is the smallest positive value, so I can substitute the largest positive value. Find the greatest speed reached by the object between 0 to 4. So at 2 it was 8 meters per second, so I'll try to substitute 4. When I substitute 4, I get it out. I'm directly writing the answer over there, so you get it out negative 10. So maximum speed is 10 meters per second. Write down an expression that represents the distance. This is again integration. So we shall do it out in the next video. And last question, cos x and tan x. Show that cos square k equals to sin k. They intersect. So cos k equals to tan k, sin k upon cos k. So cos square k equals to sin k. Hence show that the tangent to the curve y equal to f of x at p and tangent to the curve y equal to g of x at p intersect at right angles. So f prime of k will be minus sin k. G prime of k will be secant square k. Now I'm going to multiply f prime k times g prime k, which is minus sin k upon cos square k. So, but cos square k equals to, we have just proved that cos square k equals to sin k. So plug in that one. So it becomes minus sin k upon sin k, which is going to be minus 1. So therefore, they are perpendicular. Find the value of sin k, giving your answer. So, which part is that? It's part C. We know that cos square k equals to sin k. Cos square k means 1 minus sin square k equals to sin k. So we get a quadratic there. Sin square k plus sin k minus 1 equals to 0. So sin k equals to minus b plus minus square root of b square minus 4ac upon 2a. Then you'll be getting negative 1 plus minus square root of 5 upon 2. So, but we given that k lies between 0 to pi by 2, means it is in quadrant 1, means sin k should be positive. So therefore, sin k equals to negative 1 plus square root of 5 upon 2. That's going to be the answer. That completes the video. See you in the next video. Bye.